Hello guys, so welcome to our next video in the playlist Google Search Engine Charts. So in today's video, we're going to plot a 4-year NDVI time series using the function UI.chart dot image so DOI series by year. So this is the particular function which we are using today. So let's start. So let's search in the data catalog Moody's. So there are various Moody's products. So for the Terra as well as the Aqua vegetation indexes are there. So you just have to search go to more and you will find so yeah, here you find Terra vegetation continuous fields. So yearly 250 meter. So indices. So this one is the product which we are searching. So if you just go to the bands, the resolution is at 250 meter. We have two vegetation indices at a 16-day global scale. So one is the NDVI band and another one is the enhanced vegetation index band. So as you can see, the values ranges from minimum to maximum minus 2000 to 1000. So but as you all know, the NDVI value varies from -1 to 1. So the product has also provided a scale value which we have to multiply with 0.0001. So after multiplying this value with each of the pixel, we'll get the proper NDVI values which can be interpreted. So if you look at the dataset availability, it's available from 2000 to current. So I have already told you 250 meter resolution, and also its temporal resolution is a 16-day. So it means for every 16-day we'll get one new image for an area. So now we can import this. Our image collection has been imported, so I'm going to rename it as Moody's. So we need our region of interest also. So in today's video, I'm gonna use Mercury, Western Ghat region in the Karnataka as my region of interest. So you can just search the Mercury have been zoomed in. So go to satellite mode. So make sure you get an greenery cover because we are plotting the NDVI time series. So it would be helpful if you select any area with the green cover. So my geometry is imported, so I'm using just a single point as my region of interest. So my ROI is ready now. So now I have to multiply my scale value for the Moody's data. So before that, I need to filter my Moody's data also. So I'm creating a variable called filtered, because I'm gonna filter this Moody's data to my bounds with the use of the function filter bounds to region of interest. And also I would like to filter it down to date. Let's say 20. I am plotting for 24 years, so I'm starting from 2021 to 2025. So since this filter date function is exclusive of the end date, it means if you give 2025, the whatever the images which are in the 2025 year will be excluded. So I will get the 4-year data for the 2021, 22, 23, and 24. So my filtering is done now. So let's just print this filtered one in order to see do we have the image collection. So our image collection is loading now. Yeah, we have 92 elements for our point region of interest. So if you can just expand, here you will find the image Moody's with the ID and the date. So image is starting from 2021 Jan 1. So the next image is on 17th of Jan 2021. So as I've already told you, the temporal resolution of this particular product is 16 days. So after 16 days you will get one new image. So let's just also look it into the bands. So we have EVI as well as the NDVI bands as the two vegetation indexes bands, and rest are all for removing the clouds or the noisy pixels or the snow covered pixels. So this those are all the QA bands which are used. So which is of not importance as of now. So we have the 92 elements with the two important bands of NDVI and EVI, which we have filtered it down to 2021 to 2024. So let's just also multiply each of the images and their pixels with the scale value of 0.001. So I'm creating one more variable called scaled images, or simply scaled image. So I have my filtered image collection, for which I have to map a function. So you just use the function dot map and create a function and give the arguments. So this function will take each image inside this image collection, and it will return an image but multiplied by 0.0001. So let's just go to dataset again in order to confirm what's the scale value once again. So here we have 0.0001. So for both EVI and NDVI, we have the same scale value. So I have multiplied each of the image with the 0.001, and it have to return this image only. So here you just press return, and done. Our scaling is done. So let's just print the scaled image and give it a run. Yeah, again we have 92 elements. Let's just inspect any one of the image. So as you can see now, my name of the each element is just an image. So whatever its id was with the date or the mode is id numbers, so everything was lost. So if you just open, so NDVI values ranges from -3 to 3. So here you will see the integer has been converted into float values. So because I have multiplied with the scale value, so I want to also retain my properties which are there in my original image. So I just want to use the function called copy properties. So remember, you can always use control plus space in order to autofill your function. So the copy properties function needs two arguments. One is what is from where you want to copy your properties. So I am giving the argument as my image, and what are the properties you want to select from those images. So I'll just say I want to have this image property names. So whatever the names are there, property names are there in my this image, will be now copied to the scaled image. So now if you just give it a run, and we are printing the scaled image, you will get all the properties which are retained with the image collection id and their date. So all the properties will be retained so that we can plot our graph. So now we have the scaled image also ready with the 92 elements, and our modis data is also ready for the plotting. So let's just start with creating a chart. So we're creating a variable called chart. So I'm using the function ui dot chart dot image. So here you will find multiple options. So today we are using, as I've already told you, ui dot chart day of the year series by year. So this is the particular function which we are using. So it needs a few arguments. So give the collection which we need to plot. So it's my scaled image, and band name. So remember, our image collection contains several bands. So I want to plot NDVI today. So if you want to plot EVI also, just change the band name, you will get the EVI. So region of interest is my ROI, and the region reducer. So remember, if you have any kind of a polygon or a multi-polygon, so what is the mean value, or what is the reducer it want to apply across the region. So for that you should give region reducer. So because since today I'm using only a single point, this reducer won't influence much. So however, I'm using e.reducer.mean in order to avoid any kind of errors. So scale, I have already told you, it's the resolution of the modis dataset. So it's 250 meter, and same day reducer. So the same day reducer argument is that when you have multiple images in a single day, for example, if you use a sentinel dataset, you can get single in a single day you may have a multiple image. So what is the reducer you want to apply for a single day images? So remember, I have already told you the modis data is available only once in 16 days. So this same day reducer is not of our importance. So if you are using any kind of different data set, or you are deriving your own NDVI from the sentinel to data set, then you may have to give this temporary reducer. So it's possible to use mean mode or median, anything, so based on your uh, convenience. So I'm just removing this same day reducer argument, and also start day and end day also I'm removing, because I want to plot for the whole 365 days of my year. So you just close the brackets now, and let's just print the chart, give it a run. My chart is generating now. Yeah, you can see my chart is ready. So if you can just open it, so the chart doesn't look so good. So it has, on the initial days, the NDVI values are higher. So as soon as the summer occurs, the NDVI low and NDVI peak and downs are here. And here you will see the legend. For the 4 different years, you have the 4 different bands. So the title and the x-axis, y-axis, everything doesn't look so much good. So let's just modify a little bit. So I'm using the function called dot set options. So it should be a dictionary. So first of all, I want to change my curve type. So remember, the curve type should be functional, so that I can get a smooth curve instead of these straight lines with the pointed edges. So my curve type should be function, and I also want to change my title. So the current title is NDVI mean day by the year of different years. So whatever it is, so I want to change my NDVI title to be NDVI time series for the year 2021 to 2024. And additionally, I want to change my horizontal axis title or vertical axis title. So just to specify the argument vertical axis. So remember, it should be again a dictionary. So give it a title as a NDVI values, and whatever I can do, I did this. So on the x-axis, it's good day of the year. So let's just give it a run. Yeah, now you can see my chart is much smoother now. So there are no pointed edges, there are no up and downs. So for each year there is some trend which is followed. So in the initial days, the NDY values are much stable, nearly 0.8. So remember, it's a forest area, and as soon as the middle of the year comes, near to 180, or at the days of 180, the NDY values are falling, and again raising, again falling. So at the end of spring, so you're getting some stable NDVI values. So on the legend, you can see the years are mentioned to be 21, 22, 23, 24. So we have a 4-year NDVI time series data. My title is also changed to NDVI time series 2021 to 2024. And I have, on the y-axis, I have the NDVI values, and on the x-axis, I have day of the year. So this looks good. So what if I want to again modify a little bit? I want my line thickness, everything to be modified. So you just come here, you give line width option. So let's say I want to have my line width to be uh, 3, and I want my point size to be 3. So let's just reduce this line width to 2. And additionally, one more parameter is there, so that's called interpolate nulls. So this particular parameter is used whenever you have some of the null values in between. For example, in case of the Moody's data itself, the first image was available at 1st Jan, and the next image is available at 17 Jan. So you see, there is no observation between 1st Jan as well as the 17 Jan. So what happens to the values which are in between these dates? So those values will be interpolated linearly. So you have to set this parameter to true, so that you will have the readings at all the dates, and whatever the interpolations will be done will be linear. So that this is the parameter interpolate nulls. It means it is interpolating the null values linearly. So now if you just give it a run, you will generate a chart, yeah, with a good line thickness, and you also have the points wherever you have some of the readings. So as I've already told you, the first reading was at the 1st of Jan. So you have for the 1st of 2024 there is a reading, for the 1st of 2022 there is a reading. So like that, wherever the points have been seen, there we have the actual observation. So whatever in between the values are there, those are all interpolations of the null values. So we also have the legend for the different time or the year. So I hope guys you have understood how you can create this NDVI time series chart. So with the use of the function DOI series by year. So also you can set options, some of the useful options to manipulate your curve so that it looks better and good. So thank you for watching. If you have any kind of queries or doubts, you can always post it in the comment section. uh, Thank you.